Very important lesson, graph of f and f prime. First question, given a function, where do we have derivatives that are positive? We can see right here, this function has positive derivatives from -2 to -1, and then from 1 to 2. And they're actually not including 1, but they would be included 2. I don't really care about this. But we should be able to see that here, the tangents that I would graph, all their derivatives, all their slopes are positive. And here as well. Okay. And between 1 and 2, all the tangent slopes are negative. Giving us 2 points where the tangent slopes are 0. We have this guy right here and this guy right here. And since the tangent is 0, we would consider those points at -1 and 1, those are critical points. Critical points we talked about last class being points that could be locations of maxes and mins. In this situation, we do have a max at -1. In this situation, we do have a min at +1. Well, now, looking at this graph from left to right, looking at f, not really necessarily looking at the derivatives, but just looking at the function. So another way we can describe what's going on, say in the location where we have positive tangents, and in the location where we have negative tangents. So what is the graph doing when the derivatives are positive compared to the graph when the derivatives are negative, looking from left to right? Yeah, it's going up if the derivatives are positive, or it's going down when the derivatives are negative. We would say it's increasing when f prime was positive. It's decreasing when these derivatives are negative. And it's constant, or it's neither increasing nor decreasing at the 0 tangents. Well, this is interesting. This is another way we can describe a function. We can ask questions. When is a function increasing? When is a function decreasing? I could ask you, when is a function constant now? And you would know what to do. Well, you'd know the idea of it at least. A function is increasing if its derivative is positive. On that interval from A to B, everywhere on the interval. You'd say a function is decreasing if the derivative was negative. And it's constant if its derivative is 0. Okay. Now, why do we need to know this? What is this going to be good for? Well, knowing that at this critical point at -1, knowing that to the left my tangent slopes are positive and my function is increasing, and knowing that to the right of this point at -1 my tangent slopes are negative, that's telling me my function is going increasing then decreasing. That's telling me that at -1 we have a maximum. If I have tangent slopes that are going from negatives to positive at a critical point, that's telling me that my tangents that will have a minimum there. So understanding tangent slopes around a critical point will help us determine if critical points are maxes and mins. Now, if I gave you the graph, though, you can just see it's like that's a max, that's a min. But I'm going to give you a function, and you're not going to be able to graph it so easily. You're not going to have a calculator. You will be able to find a critical point and then say, okay, let's analyze the slopes of my tangents around that. Knowing those, I'll be able to tell you that is a location of a max, or that is a location of a min. Okay? So what that is called is the first derivative test. The first derivative test is a test to find maxes and mins using signs of f prime around a critical point. Test to find max and mins using signs of f prime around a critical point is what that says. Give you 4 examples. Of situations where we can have a critical point. Great. There we go. That's nice. Okay. Here's a function. The derivatives of this first function are negative to the left of this critical point C. They are positive to the right of the critical point C. F prime changes sign from negative to positive at C. Since it's going from negative to positive, the function is going from decreasing to increasing. Therefore, this is the location of a relative min. Situation here, my derivatives go from positive to negative from the left to the right at C. Which means my function's going from increasing to decreasing. Since it's going from increasing to decreasing from the left to the right, we would consider this point a relative max. For both of these, f prime changes sign. If f prime changes sign, you could have a max or a min. Because we go from decreasing to increasing, because we go from increasing to decreasing, from the left to the right. Now, in this situation, this is a derivative that's equal to 0. It's kind of like x cubed at 0. X cubed at 0 has a derivative that's equal to 0. However, we have slopes that are positive that remain positive before and after. So, it's neither a max nor a min. Here's a situation where we have a critical point. This is a vertical tangent, a tangent that's undefined. whereas all of these tangents were zeros. So we analyze the signs of my graph around it. Since I go from negative to negative, we would say both of these are neither maxes nor mins. And f prime does not change sign here. Okay, if we can understand the tangent slopes around a critical point, we can figure out if we have a max or a min. Let's do the same process given this F graph that we were talking about before. What we will do, instead of kind of marking it, we're going to use a number line. We will use number lines a lot in the graph of f and f prime. So here is my function. I know I have a critical point. At x equals -1 and 1. I'll let you catch up. It's the same function as before. And maybe if you have space, you can put this number line next to it. Who knows? What we will do on the number line is plot those critical points, and we will analyze the signs of f prime. We said that from the left of -1, all of these tangent slopes were positive. Between -1 and 1, all of these tangent slopes were negative, because you can sketch them and see. And then past 1, we said that all the tangent slopes are positive, right? Well, because of that, using the first derivative test, you could say, by the first derivative test, x equals -1 is a location of, I'm not going to write that, or I'm just going to say, is a relative max since f prime changes sign from positive to negative at that location. And you can say the same thing at 1. It's a relative min because it changes sign from negative to positive at that location. Now again, I'm giving you the graph. It's easy to see, yes, that's a max, that's a min. Piece of cake. Okay? But I'm not going to give you the graph. It's going to be a graph that's not easy to be graphed. It's going to be something that we're going to just have the function of. Or I might even give you the graph of f prime, make it even harder. Okay? So it might say, okay, I can see that's a max, I can see that's a min. But this understanding is crucial in this class and in this lesson. Okay, before we go on, I have a question. If f has critical points only at x equals 1 and x equals 4, and if I say f prime at 2 is negative, is it possible for f prime at 3 to be positive? So read that again. Let me sketch it out for you. So I got critical points at 1 and 4. Okay? So that means the derivatives are 0 or they're undefined. Let's just assume they're 0. I'm told that f prime at 2 is positive. No, it's negative, sorry. F prime of 2 is negative. The question is, can f prime at 3 be positive? No. Mr. Kaiser, you said no very emphatically. Why?
Because in order for f prime to go from negative to positive, it has to. So that be 0 and not playing. Can't have 0 between 2 and 3.
Why can't you have a 0 between 2 and 3?
Because the only zeros are 4.
Exactly. If we found the only critical points are at 1 and 4, these are the only locations where you can have 0. You can't have another location where you have a 0. So if we have a negative, the only way we can go to a positive is to have another location of a 0 tangent slope. Well, that can't exist because I found my only critical points at 1 and 4. Yes, Ms. Seifert. We would still be able to find that critical. That would still be a critical point, right? It'd probably be when my derivative was equal to undefined or something like that. Okay, so that brings us to this next thing called a test point. I only need to find the value of one point, of one tangent point on an interval to know the sine of all of my tangents. And your interval is, between two critical points. So if I go back to the last situation, if I know that the sine of f prime at 2 is negative, I therefore know that the sine of every single x value between 1 and 4 also has to be negative. The only way that can't be is if I did not find all of the critical values. If I did not find all of the critical values, well, yes, maybe we changed sign somewhere. Maybe I have another critical value here. But if I correctly found the critical values, and I know this is negative, all of them are going to be negative. That's at 1.1, that's at 3.999, that's at 3, all of those values. So that's the crucial understanding to know. If I just find critical points, I just test one value. And boom, I know all of the tangent slope values. And if I went over here and I could test a value like at 5, and I knew that f prime of 5 was positive, well, then I know my function goes from decreasing to increasing at 4. This would be a location of a min. If this was the sine of f prime at 0, if this was a positive value, that means all of the tangent slopes to the left of 1 would be positive. Since my function goes from tangent slopes are positive to negative, this would be a location of a max. Okay? Well, let's do something similar to that. I'm going to give you a derivative. This is f prime. And I gave you the simplified equation for it. I'm asking you what the critical points are first, and then I'm asking you if they are locations of relative extrema. So that's f prime, not f. I already gave you f. I already found what the derivative was. All I need you to do is to set that equal to 0. What do we get, Mr. Thigpen? Simple. Well, now we are going to use this number line to analyze the signs of f prime. We'll plot our critical points. We might say, okay, at those locations we have tangent slopes that are 0, so the sign of f prime is 0. All we need to do is test one point to the right of 3. We need to test one point between -2 and 3. And we need to test one point to the left of -2. And we will know the slopes of the tangents for all of those values in those intervals. Now, how do I do this? It's really simple. Use your simplified derivative. I know f prime is x minus 3 times x plus 2. I could distribute that if I wanted to, but it's actually going to make it more complicated. All I need to do is pick one value bigger than 3, say 5. Plug in 5 into your simplified derivative, and I don't care what the value is. I just need to know if it's positive or negative. If I plug in 5, is it going to be positive or negative? Positive. It's simple. We would have a positive value times a positive value. Telling me that the derivative at 5 is positive, telling me that all of the slopes of the tangents to the right of 3 will be positive, meaning my function is increasing when x is bigger than 3. Between -2 and 3, take a test point. One test point is all you need, 0. I have a negative times a positive. That's a negative. That means all of the slopes of my tangents will be negative there. Question?
If you know those are critical points,
yeah.
Would you even have to find multiple test points? You could just take one anywhere, and that you can find the signs for that interval, and the other interval would be alternating?
Not necessarily. There are situations where, like x cubed, we have a critical point, but then we keep increasing. If I analyze the signs around 0 of x cubed, it would be positive and positive. So you can't necessarily do that. For a lot of these, you will see the alternating signs that you're talking about, but not all of them. So do not try to take shortcuts. Plug in a bigger negative value like -5, I'd get a negative times a negative. That's a positive. So x equals 3 and -2 are critical points, but more importantly, now we can say that x equals -2 is the location of a what, Mr. Ruzicka? Is it a minimum or is it a maximum? If I go from positives to negative, my function is increasing and then decreasing. Positives mean increasing, negatives mean decreasing. This is a max. And at 3, Mr. Schlageter, sorry, it's a min. Because the derivatives go from negative to positive here. And we're looking from left to right. And that sometimes trips people up. I like to look at things from right to left a lot of times. But in this situation with these derivatives and this first derivative test, you must look from left to right. Very important. Okay, we go from increasing to decreasing, decreasing to increasing. We have a max and a min. Okay, well, that was easy. Now I'll give you the function. I'm not giving you the derivative. I want you to find the locations of relative maxes and mins. We now have just an extra little step in a process that we started last class. Last class, we started the first step. Step 1 of to find locations of maxes and mins is to do what? Find the critical points. That's it. Okay? Take the derivative of that, set it equal to 0. Well, we did that. We've been doing that. Step 2 is to analyze the signs of f prime. Using that number line, using those test points. Yes, Mr. Lucy. Yes, I totally recommend you do it too, because this is going to be easier to calculate quickly, especially using big numbers, compared to this. You can use both, but I would recommend you use the bottom one just for simplicity's sake. Plug in something like 9, positive, positive. Plug in something like 3, negative times a positive. Plug in something like 0, a negative times a negative. Telling me that this is what? A max or a min? Look from left to right. We go from positive to negative, increasing to decreasing. This is a min. Sorry, max. Whoa. Wow. Yeah. Then, from decreasing to increasing, this will be a min. Wow. Sometimes you say it so many times, you cross some wires up. Okay. Let's do a tougher one that might be a little bit funky. No. Yeah, let's do that one. Let's do it, Miss Wheatley.
Okay.
Good. Make sure you're using the chain rule. Now remember, for critical points, 0 or undefined, set your numerator and your denominator equal to 0. Make sure when we solve that x squared minus 4, and it's the cubed root of it, you could divide by 3, and then you could cube both sides. You'd really just be finding when x squared minus 4 is equal to 0. Add 4, square root, we'll get plus n minus 2. So make sure you look at plus n minus 2, and then your numerator set equal to 0. That's when x is 0. So 3 critical points, 0, positive, negative 2. Draw them on a number line. Analyze the signs of f prime. Now, again, use this simplified one that you did to rewrite so that you have a fraction. You can go positives over negatives, negatives over negatives, positive over positive. That'll help you determine your sign of f prime. Check your answers with a neighbor. A lot of you are done already. Find the locations of maxes and mins. So it would just be there. Well, could be. Let's see. Let's look at between 0 and 2, like 1. That's a positive over 1 squared minus 4. That's negative 3. Cubed root of a negative. Is that a positive or a negative? That's a negative. So you have a positive over a negative. Yeah.
So like once you get into like negative can you just like
No. No. Don't.
Yeah.
Because you could have an asymptote at 0. And you could be like increasing. My function could look like this, increasing, and then increasing.
So it doesn't have to be like
No. Well, to do this, no. And also you could have a situation where we're increasing, maybe like this, increasing to a undefined vertical tangent, and we're increasing after that. So don't be lazy. Don't be lazy, exactly. Don't be lazy. Okay, make sure we know that the cubed root of a negative is a negative. So if I'm talking about here, we'll have a positive over a positive for like 4. Positive over 16 minus 4, that would remain positive. I'm not finding values. It'd be too tough to find these values. I can use my calculator maybe for homework just to check things, just to make sure you feel comfortable with it. For 1, I'd have a positive over. In the bottom, I'd have 1 squared minus 4. That's a negative. The cubed root of a negative remains a negative. So this is a positive over a negative, which is a negative. Now, from 0 to negative 2, I have a negative value over. This would be another negative value. Cubed rooted, we'd have a negative over a negative, which would mean this was a positive. And then finally, to the left of negative 2, it'd be a negative over a positive. because -3 squared be bigger than 4, cubed root it, stay positive, times 3, be this, okay? Very, very important to be careful when we're doing this. This is it's a tricky process, and depending on the function like this, it can be hard. Meaning this has to be a min, this is a max, and this is a min. Okay, I will show you more examples of these. I'm going to do the other examples that I have on the board on the video. I'm moving forward to kind of different stuff, but the same stuff. Questions about the last thing we did? Okay. I'm giving you now a graph of f prime. This is not the graph of f. Everybody sketch down this graph of f prime. The key thing is that I'm looking for information about f. This is f prime. Looking at f prime, can somebody tell me the critical points of f? The x values, at least. You're not going to be able to tell me the y's.
-3 plus 3, 1.
Good. At -3, 1, and 3, f prime is equal to 0. You might think the critical point would be at -1 and at 2, right? Because that's where you see tangent slopes. Well, this is the slopes of the tangents of f. These are telling me what the values are when it's on the x-axis. That's when the tangent slopes are 0. When it's above the x-axis, the tangent slopes are positive. When it's below the x-axis, the tangent slopes are negative. So if I asked you when f of x was increasing, this is where f is increasing, not where f prime is increasing, what would you tell me? Between -3 and 1, because these values of f prime are positive, and from 1 to infinity, because this is where f prime is positive. Oh, sorry, 3 to infinity. Finally, we know we have these critical values at 3, at 1, -3, 1, and 3. Which ones are maxes? Which ones are mins? -3 is a minimum, correct. -3 is a minimum because f prime goes from negative to positive at that location. What about at 1? 1 would be the location of a relative max because we have positive f prime values then going to negative f prime values. I don't want to put it on top of the line, but we're talking about the function values of f prime. And finally at 3 we'd have another min. I'm going to do a couple more graphs of these so that you can look on line and see me do those examples. Those will be important for you to understand. This is the tricky part of this unit, this graph of f prime stuff. All right, thank you. All right, so let's go back and do more of these analysis problems. So let's find the relative extrema for x cubed minus 3/2 x squared. So step 1, take the derivative. Set it equal to 0 or see when it's undefined. I'll go ahead and factor out of 3x. I get critical points at 0 and at 1. Step 2, analyze the signs of f prime. Plug into our simplified f prime, but it can use your original, it just might be more difficult. I plug in a positive value like 5, I get a positive times a positive, that makes this a positive. I plug in a value like 0.5, this would be a positive, this would be a negative, so positive times a negative is a negative. And then to the left, I got a negative times another negative, so like -3, that's a negative. This would be a positive value, which means all the slopes of the tangents are positive, which means this is the location of a relative max, and this is the location of a relative min. Let's try this one, x to the 4th plus 1 over x squared, see how well this goes. Take the derivative. I could split this up into x squared plus 1 over x squared, or I could use the quotient rule. I'm going to use the quotient rule just so it stays all in one fraction. So I got f prime g minus g prime f all over g squared. So I'm going to see when this is equal to 0 or undefined. So this is 4x to the 5th minus 2x to the 5th minus 2x. So that's over x to the 4th. This becomes 2x to the 5th minus 2x over x to the 4th. Set it equals to 0 or see when it's undefined. So we'll get x equals 0 from the denominator equal to 0. Numerator, I'd factor out a 2x. I'd get 2x times x to the 4th minus 1. Split this up. So we get x equals 0 from this one. This one set equal to 0. I also get 0. But I can factor this to be x squared plus 1, x squared minus 1. So that would give me plus and minus 1 as well. So I go back into my original and I see that when x is 0, I have an asymptote. So 0 is one of those situations where it's not in my domain. So on my sign chart, I'll just put a VA over 0, just to denote that that's not going to be a location of a max or a min. It's just going to be the location of an asymptote. I will look around -1 and 1, and I will look, because this can be considered a critical value, that's not in my domain, I will include this in my number line. It's very important to do that, so we can look at how my function is reacting close to this vertical asymptote. So, in my simplified guy, let's rewrite the simplified guy. I have 2x times x to the 4th minus 1 over x to the 4th. So great thing is that the denominator is always positive, so we just need to worry about the numerator. So I plug in a value like 10, it's definitely going to be a positive times a positive, that's a positive. Plug in the value like 0.5. Well, 0.5 times 2 is a positive. 0.5 to the 4th would be a small value, minus 1 would be a negative value, make this a negative. Now I look from 0 to -1, and I like to look from right to left when I'm doing this just to work from positive to negative values, but when we're figuring out it for maxes and mins, we're looking from left to right. So negative 0.5, that'd be a negative. This would be a positive minus 1, which would be a negative as well. So this would be a positive. And then at negative 2, it'd be a negative times a positive. That's a negative. Now don't just assume it's going to go back and forth and you can, just start alternating, because you don't necessarily know it will alternate. But we will know that at x equals negative 1, we will have a relative minimum. And at x equals 1, we will have also a relative minimum. And you would not say there's a max at 0, you say there's a vertical asymptote at 0. Finally, let's do this one. So 1/2 x minus sine x, we're going to look at the critical, the maxes and mins between 0 and 2 pi. Take the derivative, set it equal to 0. We go ahead and solve that. Move the 1/2 over, divide by negative 1. When is cosine equal to 1/2? So that's when the horizontal distance is 1/2. That is pi over 3. So it won't be in the second or the third and the fourth quadrant. That's 5 pi over 3. So we will then do the same thing. Those are the critical values. We can look between pi over 3 and 5 pi over 3, and then before and after that. See if these are maxes or mins. Well, let's look at this guy as my simplified derivative. So 1/2 minus cos x. And let's think about our unit circle. We got pi over 3 and we got 5 pi over 3. Now, if we found all of the correct critical numbers, then all we need to do is take one test point. Say to the left of pi over 3. If this is pi over 3, going to smaller values, that would be like at 0. I plug in 0, I get the cosine of 0 is 1. 1/2 minus 1, that's a negative. So these are all decreasing. From pi over 3 to pi over 3, I can use the test value of pi. So in here, I'll test pi. Cosine of pi is negative 1. I have 1/2 minus a negative 1. That'd be a positive. And finally, I can look at 2 pi. We'd see this as a negative. So decreasing to increasing from left to right at pi over 3. This is a min. Increasing to decreasing should be a max. Cool. Now let's go back to these graphs of f prime. Let's make sure we understand this. Given the graph of f prime, retrieve the following information, the critical points, and this is following information of f. So this is f prime. These values on this graph are telling me the slopes of f at specific locations. I want to figure out for critical points when f prime is equal to 0. F prime is equal to 0 here and here. The function value of f prime at these locations are 0. So 0 and 2. Increasing and decreasing. Well, let's look at when f is decreasing. F is decreasing when f prime is negative, less than 0. F prime has negative values down here on the bottom. Negative values between 1 and 2. That would be where we're decreasing. Now, relative extrema. So we know we have critical points at 0. We know we have a critical point at 2. So our relative extrema automatically is definitely not 1. That is not going to be the location of relative extrema. Okay? It'll be a different location of something that we'll look at next class, but this is just the relative extrema of f prime. I want to find the relative extrema of f. So I need to see when f prime changes sign and in a specific way. Well, changes sign from positive to negative at 0. That means we're going from increasing to decreasing. That is a max. And we're going from negative to positive at 2. which means this is a min. Let's do a couple more. Look at this graph for which x does f of x have a relative min. I'll let you look at it for a second, and you tell me where f has a relative min. And this is f prime. So if you're trying to say, oh, a relative min at 1, that's wrong. There is no relative min at 1. Where would the relative min of f be? Well, these are negative values. These are positive values. You got zeros at -4, -1, and 4. So that's locations of horizontal tangents or critical points. The only way we have a minimum is if f prime goes from negative to positive, goes from negative to positive at -4, goes from negative to positive at 4. Those are the locations of a relative min. Second question is, when is f, for what x is f increasing? F is increasing when f prime is positive. F prime is positive between -4 and 1, and also from 4 to infinity. You can say it like that. Next question, where would f have horizontal tangents? So here's the graph of f prime. Again, this is f prime. It's very important to see that this is the graph of f prime. Horizontal tangents occur when f prime equals 0. When does this graph of f prime equal 0? At -4 and 1. Now, question is, where would f have a relative extremis? So let's look at -4, let's look at 1. Well, we go from negative values to positive values at -4 from left to right. So that means this would be a relative min. But at 1, I go from positive values to positive values. That means this is neither a max or a min. You could have a situation at 1 on the graph of f where we have increasing, then a 0, and then we go back up to increasing again. You can look at that like this: increasing, a 0, then back up to increasing. Okay? A couple more. Where does f have relative maxima? I look at the graph, see when f prime changes sign from positive to negative. That's where you're going to have a relative maximum. Positive negative occurs at 3. When is f increasing? When is f prime positive? F is increasing from -4 to 3. From -4 to 3, all of my f prime values are positive. Let's look at this one. What type of point on f is x equals 0? So we're given the graph of f prime again. I see that at 0, my derivative values go from negative to positive. Negative derivative values, positive derivative values. So we go from negative to positive. That is a min, a relative minimum. If f had a tangent slope that was undefined, sketch a possible graph of f prime. Well, let's look at a graph of f with a undefined tangent slope. An undefined tangent slope is typically a vertical tangent slope. You can use a sharp point, but we can use a vertical one. So here the slope is undefined. So let's think, a graph of f prime. For this guy, and we'd be centered around this critical point right here, we have positive tangents that keep increasing until we get to this vertical tangent, which is like infinity. And then we'd be coming from infinity and we continue to increase. That's a possible f prime. There's all sorts of ones like that. You can think about this. That would be a negative and then a positive. We've done all sorts of them. Don't know why I included that question. All right, so the final question. Very important question. We got this derivative. And this was the question that a lot of people asked during classes. Can we just assume they're going to alternate? Well, watch this. If this was the derivative, and I ask you what the locations of the relative extrema are, you're going to assume, well, it's got to be 2, 3, and 4. Because if I set this equal to 0, that's going to be it. They're not asking you, like, where are your maxes min, just where are your relative extrema. Well, this is why, and this is example is why, it's so important to check the signs of f prime at these locations and around these locations. So let's start with, let's go from left to right. Let's start with 0. I start with 0, I get a negative times, this would be negative 3 squared, which would be a positive, times a negative value cubed, which would also be a negative. So this would be a positive. Negative times a positive times a negative. Let's look at 2.5. Make this first guy positive. It'd make this second guy also positive because it's 2.5 minus 3 squared. And then this would be negative cubed, which would stay negative. This is a negative. Let's look at between 3 and 4. So I plug in 3.5. We get a positive. Get a positive. Here, we'd get a negative. So positive, this is positive, this would be a negative 0.5 cubed. That would remain negative, so that would be a negative. Finally, greater than 4, positive, 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 boom. So at 3, we are going from decreasing to decreasing. 3 would not be a relative extrema. 3 would be just one of those interesting points where your graph is decreasing, flattens out, and then it keeps decreasing right here. Okay? So that would be the critical point. However, it is not a relative extrema. So this would be the location of a max. This is the location of a min. Last problem. Good problem to know how to do. You'll see a problem just like this on an AP test. You see it on your test that you'll get from me. If we have f is equal to this function of x squared minus 3x, and g prime, I'm told g prime is negative for all x's. When is f increasing? So I'm trying to figure out when f prime is positive. Okay. Well, we need to figure out what f prime is first. Now, when I'm taking the derivative of this thing right here, we have to understand it's a composition. It's g of some stuff, and then x squared minus 3x. So when I take the derivative of this, it would be g prime of this stuff times the derivative of the stuff. Okay? So this is the derivative. Well, I need to figure out when f is increasing. Well, the first thing I would need to do is figure out when f prime is equal to 0. And you're probably wondering, well, how do I figure out when g prime of x squared minus 3x is equal to 0? Well, you don't have to figure this out. This is helped by that statement. Look at that for a second. We are told that g prime of x is always negative for all x. That means this is negative everywhere. It can never be 0. So all I need to worry about is when this is equal to 0. This is equal to 0 when x is equal to 3/2. Well, now I can kind of analyze using our only critical value. This is our critical value. This is our possible max or min. By analyzing the signs of f prime around 3/2. Well, I start by plugging in a test point, let's say 5. Plug in 5 here, and this is my derivative here. Plug in 5, I get a positive. But if I plug in 5, I'm still going to have a g prime that's negative. Even though x squared minus 3x is positive, g prime is negative for every x. So this is a positive times a negative. That's a negative. Finally, if I take something like 0, I'd have a negative value when plugged in. And then this would also stay negative, even though it would be, 0. So this is a negative, and then this would be a positive, because a negative times a negative is a positive. So when is f increasing? When x is less than 3/2. Or you can say from negative infinity to 3/2 is probably better. Okay, very interesting problem. Makes you use your noggin a little bit, but a good problem. All right, that's it.